So we will be starting with the new topic, that is a section of solids. In section of solids, you have this object is cut, that is called as sectioning. Object is cut, that is called as the sectioning of the solid. And when you do that, the details of the objects are exposed. So in industry, many times sectional orthography is used to give details of a complex object. To give details of the object with complex object or complex features. Complex features. Now the topic which we are studying is section of solids. So we are going to study it in a slightly different manner. So when we are studying this topic, we have, as far as your syllabus coverage is concerned, we have limited the scope, and we are going to study in a particular manner, in such a way that the section plane will be inclined to one of the reference plane, that is either HP or VP or VP, and it will be perpendicular to other. So it will be either inclined to HP and perpendicular to VP, or inclined to VP and perpendicular to HP. These are the only two varieties. So we will see what are these various types of section planes. Okay. So these two types of section planes, they are named as auxiliary inclined plane and auxiliary vertical plane. And they are abbreviated as AIP and ABP respectively. Okay. So let's try to understand what is each of these types is. Okay. So when you say auxiliary inclined plane, this section plane is inclined to HP, horizontal plane, and perpendicular to VP. Okay. So this section plane will be seen in front. Alright, so section plane will be seen in this view. Alright, so suppose this is a section plane. So this is the section plane, and the observer is here. This is the observer, and this is the section plane in front. Now the part of the object which is lying between the observer and the section plane is removed. So this part which I am shading, that part is removed, and the rest of the part is retained, and the projections are drawn. Now in case of auxiliary vertical plane, the section plane is perpendicular to HP, horizontal plane, and inclined to VP. So now in this case, the section plane is seen in top view. Right? So let's see an example of the section plane. So this is the section plane. So this is again the section plane in top view. So this is the auxiliary vertical plane. And again observer, this is the position of observer. Part of the solid between the section plane and the observer is removed. and the projection is and projections are. How these projections are drawn, we will see that when we do the example. So now one more thing you need to keep in mind is, whenever section is taken, smallest portion is removed and a largest portion is retained. That is a rule that we have to follow whenever we do section of solids. Okay. So this is some basic stuff about section of solids. Now we will start with first example. Okay. First problem of your assignment. Alright. So I will just read the question. A pentagonal pyramid resting on its base in HP with side of the base parallel and near to VP. The base edge is 40 mm and axis height is 80 mm. It is cut by a plane inclined 40 degrees to VP and perpendicular to HP. So that is a auxiliary vertical plane, right? And passing through the point 12 mm away from the axis towards the observer. 12 mm away, and it is from the axis and it is towards the observer, means it is the section plane. What does that mean? Towards the observer means the section plane is near to the observer. Right? So we'll start with the solution, and then you have to construct this pentagonal pyramid. Okay. Now when you construct this pentagonal pyramid, take this side parallel to XY. Okay. So side ED is parallel to XY, and length of ED is how much? It is 40 millimeters. So ED is 40 millimeters. Right? And angle between these sides, since it is a pentagon and it is a regular pentagon, it should be 108 degrees. 108 degrees. So all angles should be equal to 180. This also should be 108 degrees. Okay, so you can draw ED. So how to draw that? You should be familiar with that. Construct this regular pentagon of side 40 mm side, and take ED parallel to X. Okay. So length of the side is 40 mm and angle is 108 degrees. So that is the outline of the pentagonal pyramid. Okay. Now since it is a pyramid, in top view you should also see the slant edge. Okay. So now to construct the slant edge, what you need is you need to first locate the apex. Okay. And I have already explained how to find the apex. To find the apex, what we are going to do is drop perpendicular from any two adjacent corner to opposite sides. So let's choose E and D. So from E, we'll drop a perpendicular. That will intersect the midpoint of BC, and from D, I drop another perpendicular that will meet the midpoint of AB. Okay. Wherever these two perpendiculars meet, mark the intersection, that is your apex. And join, so that is your apex. Join all the corners to this apex. Okay. Corners. Oh. This is your apex. So that completes the top view. Now we'll construct the front view. So to draw the front view, draw projectors from all these corners, from A to E. There are 5 corners, and wherever they meet with the XY line, mark those points. And from this middle centermost point, draw another vertical line, construction line, that is for the axis. Okay. The axis height is given as 80. So this is for the axis. Now as you know, axis is actually a center line. It is like a center line. Yes, but I have drawn this as a solid line because the edge OB overlaps the axis. The axis. Okay. So whenever such thing happens that the edge is overlapping the axis, the preference is always given to the edge. Right? So that is why I have made that dark, and similarly make the base dark. That is the base dark, and mark all the points in front. That is, so in front of it will be A dash, B dash, B dash, D dash, and C dash. And now after that, construct the slant edges by joining all these points, that is A dash to E dash, to the apex. The apex, that is, apex is your O dash, your apex. So one by one, join all the points. Okay. So these are the slant edges, in front. So that completes the outline of the object in front view and top view. Now what is given, the data is given that the section, the solid is cut by auxiliary vertical plane inclined at 40 degrees to it. Okay. So the section plane is auxiliary vertical plane and inclined at 40 degrees to B. Okay. And so since it is auxiliary vertical plane, obviously it is going to be inclined at 40 degrees to P and perpendicular to HP. That is the definition of auxiliary vertical plane. Okay. And one more additional information is given that the section plane is 12 mm away from the axis. and it is 12 mm away and it is towards observer. Alright. There are some, so all these are various conditions that are need to be satisfied. So since it is an auxiliary vertical plane, the section plane will be seen in the top. Section plane in top. So now to construct the section plane, first taking the apex O as the center, draw a circle of radius 12 mm. Okay, so draw a circle of radius 12 mm. And now you have to draw the section plane such that it is tangent to this circle. Tangent to circle. Alright. So to do that, what you have to do is make your drafter or your roller scale inclined at 40 degrees and move the drafter towards the circle or the roller scale towards the circle inclined at 40 degrees such that it becomes tangent to the circle. Alright, so your section plane is going to look something like this. Alright, so this is your section plane. So all the conditions are satisfied. So what you can do is you draw a reference line at 40 degrees somewhere here. So this should be 40 degrees. Okay, and then make your, this is your reference line. Draw a reference line 40 degrees and make your drafter or your roller scale, drafter or roller scale, whatever you are using, parallel to this 40 degree line. And then move this, move your roller scale. This is your roller scale. This is your roller scale. Move this roller scale towards the circle till this line, till you get this line tangent. Alright, till this line becomes tangent. I hope you understood the construction. Okay, so this is how you are going to construct it. Draw the roller here. Right? So your roller is inclined to 40 degree, and then it is, you have made your roller, edge of the roller parallel to the 40 degree line. This is your roller scale, and then move this towards the circle till it becomes tangent. Right? So that will get you the section. Okay. Mark all the points on the section plane which intersect with the slant edges as well as the wedge edge. Okay. So you should get these 4 points. 1, 2, 3 and 4. Right. So you get 4 points of intersection. Okay. 1, 2, 3 and 4. 1, 2, 3 and 4. So this is your section plane, and these are the points of intersection of the section plane with the base edges and the slant edges of the pyramid, and it is constructed in front. Now we are going to draw the projection of this section in the front. Alright, so to do that, what we are going to do, we are going to construct the projectors from all these 4 points one by one. Alright, so starting from 4, drop a projector vertically up, and if you see, point 4 is on edge DC. Alright, so wherever this projector intersects the edge DC in front view, mark that point. So this DC is on the base, that is on the XY line. Alright, so this is your point 4. Similarly, point 3 is on slant. So this is base edge. Let's differentiate that. And point 3 is on slant edge. Slant edge OC. Okay. So from 3, drop a projector vertically up. And mark the point of intersection of the projector with slant edge OC, that is in front view it is O dash C dash. Here also it should be D C dash. This is the point 3. Okay. Then next, mark point 2. Okay. Now when you have to mark point 2, you cannot directly mark it on. So point 2 is on OB. Alright. So in front view, it will be on O dash B dash. So you have to mark point 2 on O dash B dash. So you cannot mark this point 2 directly because if you draw the projector, there will be no intersection with O dash B dash. So what you have to do, rotate point 2 onto edge OA. Right, and mark the point of intersection. So rotate O2 and mark intersection point with OA. Alright. Now from that point, from the intersection point, drop the projector vertically up. And again mark the, so the point was transferred on edge OA. So you are going to project the point. So project it on O dash A dash, obviously. Alright, so it is transferred to OA, so it is being projected to O dash A dash. This is a point of intersection. Now from the point of intersection of O dash A dash, draw a horizontal projection. Alright, and mark the intersection with O dash B dash. So mark intersection with O dash B dash. Okay. That is your point 2 dash. Okay. So that completes 2 dash. Now only one more point is remaining, that is 1. So point 1 is on AB. So draw projector. Perpendicular to XY. Mark that one. Point of intersection. So that is your point. So point 1 is on AB in top view. So in front view, it is on A dash B dash. So mark that point on A dash B dash. That is your point 1. Alright. So now all the points are marked in the front view. All linked on the slide, and join all these points. Join all the points. 1 dash to 2 dash, and show hatch clearance. this outline should be dark. Okay. Now, as you can see, I have not made the outline very dark, so the, the observer is over here. This is the observer. Okay. So as I have explained earlier, the part of the object between the section plane and observer is removed. Okay. So what, and the part which is behind is retained. So whatever is removed is made light. Okay. And whatever is retained is made dark. So I am going to make what the part which is retained dark. Okay. So the whatever part is shown in dark, that part is retained. Now similarly, I am going to do the similarly I am going to make the outline dark. Okay. So as you can see, this, let me just clean up the screen. Okay. If you see this small triangle, this triangle, it is 3 dash 4 dash C dash. Alright. So if you see, the corner C is removed. Alright. So this triangle, this portion is removed. Alright. So keep that light and make the rest of the object dark. Now one more thing before you make this dark, we have to discuss the visibility of edge O dash E dash. So if you see edge, this edge O dash E dash, this edge is hidden. Alright, this is hidden. So this will be a dotted line, hidden line. And rest of it is also this part which is lying outside, this small portion which is lying outside of the section plane, you also show it by hidden line, dotted or hidden line. Okay. Do not show any hidden lines inside of hatching. Okay. Alright, so all these things you should keep in mind and make the outline. Alright, so this is the final print. Okay, so I am going to erase the notes. Okay, so this is the final sectional front. Alright. So this is the sectional front view, this is top view. Now we'll also do the true shape of the section. True shape of section. That is this hatched area. Okay, what is the true shape? Okay. So to construct the true shape, what we need to do is we need to make this section plane parallel to XY. Okay. So make the section plane parallel to x1. Alright. So how to make that? See, you have to just reconstruct this section plane over here and make it parallel. Okay. So all these distances are taken from here. Okay. These are the distances you have to take. It is 1, 2, 2, 3 and 3, 4 is equal to 1, 2, 2, 3 and 3, 4 in the actual section. Right. Once you draw the section plane, draw projectors from all the 4 points. Okay. So starting with 1. Okay. So drop a projector from 1. Now 1.1 lies on the xy line. Okay. So mark the intersection point. So that is your 1 dash. Okay. Then drop a projector from point 4. Point 4 also lies on the xy line. Mark the intersection point, that is point 4. Okay. Similarly, draw projectors from 2 and draw a horizontal projector from the front. Okay. Wherever they intersect, mark the point, that is your point 2 dash. Okay. Similarly, drop a projector from 3 vertically up and horizontal projector from 3 dash. Wherever they intersect, your point 3 dash. Okay. Join all the 4 points, that is the true shape. So this is your true shape. Right. And show this. So this is the complete solution. I have just erase all the ink on the side. This is the final solution. Alright. Okay. Thank you. I hope you will be able to complete this. If you have any questions, please contact or ask me.